In this video, we'll use the tangent method to find the height of this tree model. This model represents a wide-spreading tree on sloping ground. The first step will be determining where the point on the ground below the top of the tree is. In a previous video, we took a look at cross triangulation, which is a method for finding that spot. But in this video, we'll just go ahead and use a plumb bob. Alright, so this is the top of the tree model. And this is the point directly below that on the ground. And from there, we need to establish a baseline for our tangent-based measurement. So to start with, we're going to take a tape measure and start right at that point below the top of the tree. And we're going to move back far enough so that we can see the top of the tree. And in this case, we'll use 17 inches. All right, and the other aspect of this is we need to go ahead and get an angle measurement as well. And of course, our eye level won't be right on the ground, so in this case, we're 2 inches above the ground. And down here, we don't measure directly to the ground. We'll also need to take our angle measurement so that it is also 2 inches above the ground. And in this particular case, we have an angle of 11.5 degrees. And let's go ahead and show the triangle that we've created. So again, here's our level of our eye. And we have a distance of 17 inches. And we're 2 inches above that here and 2 inches above that here. Okay? Which means that this line is also 17 inches. Right there. Okay, so we have an angle of 11.5 degrees and basically this is the hypotenuse of this right triangle is 17 inches. So what we need to find out is we need to know what this side of the triangle is. And that will serve as the proper baseline for our tangent-based height measurement. And to find that side of the triangle, we need to utilize the cosine formula. Let's go ahead and write that down. So we'll call this angle our angle x. So let's take the cosine of x multiplied by the hypotenuse, and that will equal our adjacent side. Okay, so we'll take the cosine of 11.5 degrees multiplied by 17 inches. And I did the math on this with a scientific calculator, and that works out to 16.7 inches. Alright, so in this case, we've used cosine, and by utilizing the formula, we found out the proper baseline for our tangent-based measurement of 16.7 inches. Okay. Okay, so from there, we can go ahead and do our tangent-based measurement. And what that essentially will be is the distance, the vertical distance from our eye level to the top of the tree. So in this case, let's take a look at that. All right. There we go. So again, this distance will be our baseline, which is 16.7 inches. And then we need to take an angle measurement to the top. And then from there we can use a tangent formula to find that opposite side, to find out that height above eye level. Okay. So in this case, we need to go ahead and take an angle to the top. Now there's a little bit of swivel here in the field. It's not so pronounced, but on the small scale, I'll actually have to move this tripod up a little bit so that way when I swivel the clinometer, the eye level is still at 2 inches above the ground. Alright, so in this case we have an angle to the top of 46.7 degrees. And from here we can go ahead and do the tangent-based measurement. And we'll start with a formula. So we'll take the tangent of our angle we'll multiply by that adjacent side, and that is going to give us that opposite side. All right, so we take the tangent of 46.7 degrees, multiply by that 16.7 inches of baseline that we determined. And I did the math again with this one, and this will just simply be pressing tan on the scientific calculator, entering 46.7, and then multiplying by 16.7 inches, and we arrive at 17.7 inches. Some scientific calculators might have a slightly different sequence of entering it. All right. So again, here's our triangle at our baseline of 16.7 inches. We had our angle of 46.7 degrees. We did the math on that, and we found this opposite side, which is the height from our eye level to the top of the tree of 17.7 inches. Okay, so let's keep track of the measurements we've done so far. We'll call that the point above eye level, 17.7 inches. And we already know that we have 2 inches to deal with down here, so we can go ahead and mark that in. Okay. All right, so from here, we need to take a measurement, basically a straight line measurement down to the mid-slope of the tree model. Since this time we are on a slope, we want to go halfway between the downslope and the upslope side. Okay, so with our measuring tape, right there, and this time staying at the same point here, we have 23.5 inches. All right, so we need to angle the clinometer down again. There we go. Okay. All right, let's go ahead and show the triangle that we're going to be creating this time. Now again, our eye level is 2 inches above the ground, and that's why down there we have, when we go to do our angle measurement, we're going to also point at 2 inches above the ground. We would actually go down to the tree, mark that, or have somebody stand down there for us and do that. So in this case, we have the distance of 23.5 inches, and we're 2 inches higher here and down there, so we just move that up. So we know that the distance of this side is 23.5 inches, and then we need to go ahead and take an angle measurement going down. Now the slope of this board is consistent all the way to the base of the tree. In the field that might not always be the case, so in the field we'll always want to go ahead and take that measurement. But in this case we know that we have the same angle. It goes from here, it crosses right there, and then goes down to 2 inches above the base of the tree model. And again, that was 11.5 degrees. And you know what we could do is we could take that distance of 23.5 and we could take that angle. We could utilize cosine again. We could get a new baseline for a tangent-based measurement to the bottom. Or in this case, we could just simply do the sine formula and come up with the same answer. So that'll save us a step. So let's go ahead and do that. All right. So in this case, we're going to do the sine of our angle multiplied by the hypotenuse, and that will give us the opposite side. So we have sine 11.5 degrees multiplied by 23.5 inches. And I did the math on that, and that works out to 4.7 inches. All right, so scale this better. So that was our top, eye level to the top, and now we have our eye level to the 2 inch mark above the base of the tree model. 4.7 inches. And essentially, if we add these up, we have these three segments, and this total is 24.4 inches, which is the vertical distance from the midpoint of the tree to the very top of the tree. Now, one thing I will add is with a laser rangefinder with a built-in clinometer, we actually could have just, with 2 presses of a button, done all of this math and just added 2 numbers together. We would have shot directly to the top, and we would have shot to the midpoint of the base, and we would have done 2 sine calculations, which would have been done internally inside of that hypsometer or laser rangefinder with the built-in clinometer, and we'll take a look at that in a future video.